This is a lesson for R-8. This covers chapter 5 that we just did a month ago. All right, so this is all the information from chapter 5 with scatter plots. So when you take a look at a scatter plot, remember that you always go from left to right, just like you read a sentence. So with positive scatter plots, remember the general trend of the data is that it's going up for positive. As we go from left to right, the general trend of a negative scatter plot is that it's going down. No, the dots are all over the place. You can't tell if they're going up or going down or what they're doing. Linear, basically the general trend of the data is that it forms a straight line. It could go up or it could go down. It could be both, all right? And then non-linear is a U-shaped graph. It might go up and down like this one does, or it might go down and up like this one does, where it's like a U shape. They love these type of questions on your state test as a multiple choice question. The next type is creating a scatter plot. So when you create a scatter plot, you just have to look at your data points and graph them. So like this first point is 8, 20. So we would go over to 8, we'd go up to 20, and we would put a dot right there. Remember that in a scatter plot, you do not connect the dots, all right? You don't connect the dots in a scatter plot. If you are asked to draw a line of best fit, remember that the line of best fit would look like this. You want about half of your dots above, you want half of your dots below. So it would look something like that. It doesn't have to touch all the dots. An outlier. Now remember, when you have to write the coordinates for an outlier, coordinates are always written x comma y. X is how many you go over. Y is how many you go up or down. So when we take a look at this scatter plot, the general trend of the data is that it's going up like this. These 2 points right here, these would be outliers because they're far away from all the other dots. So if we wanted the coordinates of this one, we would go over to 2002 and we would go up to, I'd say approximately, I'm going to say 39. Right, it might be like 39.5 or something like that, but it would be over to 2002 up to approximately 39. Outliers don't always have to be below. If you had a random dot up here, this one would also be an outlier. When we take a look at drawing a trend line or line of best fit, you want a line that goes in the same direction as all of your data. So if it's going up, it would go up. If it's going down, it would be going down. This one happens to be going down. You want to go right through the middle of the data field, all right? You want about half of your points above and you want about half of your points below the line. It does not necessarily touch each dot, all right? And ignore any outliers. If it is no association, meaning that the dots are randomly all over the place, remember that you cannot draw a trend line. To make an estimate of future points, sometimes you're going to have to extend your trend line. So if we draw the trend line here, our trend line would look like this, basically, where you have about half the points above, about half the points below. If they wanted an estimate for 12, you have to go over to 12, go up to your trend line, and see where that trend line is. It happens to be right there. If we go straight across, that is at 70. Now, they won't always make you make an estimate for the end. What happens if they made you make an estimate for where 7 would be? Well, then you would go over to 7, you would go up to your trend line, and then you'd have to see where it lands over here. So maybe 7 would be approximately 53 or something like that, all right? So you just go over to where it says to, go up to your trend line, and see where it's at. The next part is, does the table form a linear function? Yes or no? You have to figure out your change in your y over your change in your x. So when we go to look at that, you need to look and see how you're going from X to X to X and from Y to Y to Y. So to get from 0 to 1 to 2 to 3, we're adding by 1, adding by 1, adding by 1. To go from 5 to 10 to 15 to 20, we're adding by 5, adding by 5, adding by 5. Therefore, when you do your change in your Y over your change in your X, you have 5 over 1, 5 over 1, and 5 over 1. This would be a yes as an answer. In this middle one, to get from 0 to 2 to 4 to 6, we're adding by 2, adding by 2, adding by 2. To go from Y to Y to Y to Y, we're adding by 2, adding by 3, adding by 10. When you do your change in your Y over your change in your X, you would have 2 over 2, 3 over 2, and 10 over 2. That would be a no, because they're not all the same. Now, sometimes they're going to try and trick you by doing ones side to side like this. You have to be careful. You still have to go from X to X to X and from Y to Y to Y. So going from 0 to 3, we're adding by 3. 3 to 6, we're adding by 3 again. But then with your Y's, you're going from 1 to 6, so we're adding by 5, 6 to 11, so we're adding by 5. So change in Y over change in X, we would have 5 over 3 and 5 over 3. Those are both the same, so our final answer would be yes. You could also do these questions a little bit differently by graphing the points and then seeing if it forms a straight line or not. Because when it asks, does it form a linear function? They want to know if we graphed it, does it form a line or not? So let's go ahead and try 2 of these actually. So how do you get from -5 to -4? Well, we're adding by 1. How do you get from -4 to -3? Again, we're adding by 1. How do you get from -3 to -2? We're adding by 1. Then for your f of x or your y column, how do you get from y to y? From 2 to 4, we're adding by 2. How do you get from 4 to 6? We're adding by 2. How do you get from 6 to 8? We are adding by 2. So when you do your change in your y over your change in your x, we have to do 2 over 1, 2 over 1, and 2 over 1. Those are all the same. So our final answer doesn't form a linear function. It would be a yes. In this one, you have to go from x to x, so we're adding by 1. X to x, we're adding by 1. X to x, we're adding by 1. And x to x, we're adding by 1. When we take a look at our y's, 10 to 12, we're adding by 2. 12 to 15, we're adding by 3. 15 to -10, we are subtracting by 5. 10 to 11, we're adding by 1. So we would have change in your y over your change in your x. We would have 2 over 1. We'd have 3 over 1. We'd have -5 over 1. And we'd have 1 over 1. Those are not all the same. Therefore, does it form a linear function? No, it does not. On the next one. Now this, if you think back to when we did chapter 5, this was the hardest part for most people, was finding the equation of the trend line. So again, when you write an equation of a line, you have your y equals and you have your x. Your slope goes in front of your x and your plus or minus is after the x. The first thing that I would do is I would find my y-intercept. My y-intercept, remember the y-intercept is where the line crosses the y-axis. So my y-intercept is right here at 0,15. That 0,15 is your plus or minus after your x. Now, on your homework, these points will be already chosen for you. You want to choose 2 points that are on the line. So I'm choosing 0,15, which is this point right here, a y-intercept. And I'm choosing 110, which is this point right here. Remember that all points are written x comma y. So 0 is an X, 15 is a Y, 100 is an X, 10 is a Y. 0, 15 is your first point, so these get 1s. 100, 10 is your second point, so these get 2s. Then what you need to do is you need to sub them in to your slope formula. If you think back to chapter 3 stuff, it is y2 minus y1 over x2 minus x1. So when we go to sub these into the formula, you would have 10 minus 15 over 100 minus 0. Subtract going across the top, subtract going across the bottom, we end up with -5 over 100. That -5 over 100, if we divide by 5 and divide by 5, it would reduce to -1 over 20. That's your slope. That's the number that goes in front of your x for your equation. So let's try one of these. So the first thing that I, again, like to look at is the y-intercept, where the line crosses the y-axis. The line crosses the y-axis right here, and that point is 0, 4, over 0 up to 4. In your equation, you always have a y equals, and you always have an x. So that 0, 4, that plus 4 goes at the end after our x. Now what we want to do is we want to find our first point. I'm going to use that 0, 4 as my first point. And the second point, I'm actually going to choose over to 8 up to 6. I'm going to choose this point right here. It's on the line where the line crosses that background grid. So I'm going to use 8, 6 as my second point. All points are written x, y. So this is an x, this is a y, this is an x, this is a y. This is your first point, so these get 1s. This is your second point, so these get 2s. We need to sub them into the slope formula. Our slope formula says y2 minus y1. So we have across the top 6 minus 4 over x2 minus x1. So we have 8 minus 0. Subtract going across the top, subtract going across the bottom. That is the number that goes in front of your x, 2/8. If you wanted to reduce it, you could. There's nothing wrong with that. On the state test, if this was a multiple choice question, you'd see the reduced version of 1/4 instead of 2/8. But either of those would be fine. And that is the number that goes in front of your x. When we take a look at the last type of question, you have frequency tables. When somebody took a survey question, somebody asked, do you like lasagna and do you like tacos? So there are 4 people that like both lasagna and tacos. There were 7 people that like lasagna, but not tacos. There were 9 people that like tacos, but not lasagna. And there are 5 people that don't like either. Remember that when you go to add these, they have to add up, going straight up and down and going straight across. This bottom number, 25, that is the total number of people surveyed. All right, that is the total number of people in your survey. So relative frequency then are your percentages. You need to use these numbers from our frequency table to find our percentages. The way that you do that is to do the number divided by the total. All right, the number divided by your total. And then what you do, because you get a decimal, is you have to move the decimal point over 2 places to the right to make your percentage. So if we take a look at people who like lasagna and tacos, there are 4 people total out of the 25. So you're going to divide 4 divided by 25. Top divided by bottom, you get 0.16. Then move your decimal point 2 places to the right to give you 16%. And you keep on doing that with all of them. The number divided by the total, move your decimal point over 2 places to the right to get your percent. This number in the bottom right-hand corner should always be 100%. Just like your frequencies add up going up and down and going across, your percents will do the same thing. So let's actually try one of these. This is the last one. So this one says 8 students in a class were asked 2 questions. They were asked if they play on a sports team and if they're learning to play a musical instrument. So this first person said no to the team, but yes to an instrument. No to the team, yes to the instrument. We're going to put 1 little tally mark there. Next person said no to both. So no and no. We're going to put 1 little tally mark there. The next 2 people said yes to the team, but no to an instrument. So we're going to put 2 tally marks there. Next person said yes and yes. Next person said no and no, or sorry, no and yes, but those are the next 2 people. So no to the team, yes to an instrument. So we're going to put 2 tally marks there for the next 2 people. And the last person in the survey said yes and yes. So adding up our tally marks, we have 2 people here, 3 people here, 2 people here, and 1 person here. You have to add your rows going across, add your columns going down. So there are 5 total people playing an instrument, 3 total people not playing an instrument, 4 total people on a sports team, 4 total people not on a sports team. Add them up, and you have 8 total people in your survey. So now what you're going to do to find your percentages is we need to do the number divided by the total. So if we're looking at people who play both on the sports team and an instrument, we're looking at 2 out of 8 people. Top divided by bottom, 2 divided by 8 is 0.25. Then what we need to do is move our decimal point over 2 places. So what we really have is the percentage of 25%. 25% of the total people surveyed played on a sports team and played an instrument. If we do the next one, the next one is instrument and no team. That would be 3 out of 8. Top divided by bottom, you get 0.375. Move your decimal point over 2 places to the right. So we have 37.5%. Sorry, my mouse is not cooperating with me. On the next one, we would have total people playing an instrument would be 5 out of 8. Top divided by bottom, 5 out of 8 is 0.625. Move your decimal point over 2 places. So this would be 62.5%. You would keep on doing that, right? So this next one would be 25% again. This next one, you do 1 out of 8 and get 12.5%. The next one would be 3 out of 8, which is that 37.5% again. And the next one would be 4 out of 8, which would be 50%. Next one would be 4 out of 8, which would be 50% again. And then this one in the bottom right-hand corner is always 100%.